When you think of underwater tunnels, you might picture massive machines boring through solid rock, carving out a path deep beneath the riverbed or seabed. But here's a surprising twist. Not all underwater tunnels are made this way. In fact, some of the world's most impressive underwater passages aren't bored at all. They're assembled piece by piece in a process that's as much about creativity and precision as it is about brute force and engineering. Instead of drilling through the earth, engineers use a method that's almost like sculpting a giant clay masterpiece. Imagine building a tunnel the way you'd build a life-size sculpture, section by section, each piece carefully crafted and then snapped together. It's a process that combines artistry, engineering, and a bit of logistical magic. Let's break down how this incredible construction feat actually works. Picture yourself as a sculptor, but instead of working with small lumps of clay, you're handling blocks the size of train cars. Each tunnel section is like a massive building block, shaped and prepared with meticulous care. The process starts on dry land, where these enormous segments are cast in molds, much like a potter shapes clay on a wheel, only on a scale that's almost hard to imagine. In huge factories or open-air construction yards, teams of workers and engineers pour concrete into gigantic molds, reinforcing each section with steel to give it strength. These workshops buzz with activity as every detail is checked and double-checked. The sections are designed to fit together perfectly, with smooth edges and precise measurements, because even the tiniest gap could spell trouble once the tunnel is underwater. And these aren't just any building blocks, they're colossal. Some tunnel sections stretch over 200 meters in length, which is longer than 2 football fields placed end to end. Imagine standing next to one of these segments. It would tower over you like a concrete whale, waiting to be set afloat. Once a section is finished, it's sealed at both ends with watertight bulkheads, turning it into a giant hollow float. Then comes the next act in this engineering ballet. Tugboats arrive to tow these floating giants out to the construction site. Picture a parade of enormous toy boats gliding across the water, each one destined to become part of a tunnel beneath the waves. Meanwhile, before any tunnel section can be placed, a trench must be prepared on the river or seafloor. This is no small task. Massive excavators and dredging barges work tirelessly, scooping out a channel in the muddy bottom, much like drawing a line in wet sand at the beach, but on a scale that requires heavy machinery and careful planning. The trench must be deep and wide enough to cradle the tunnel sections, keeping them safe from shifting currents and the weight of the water above. Now comes the tricky part, the moment when precision and teamwork matter most. Engineers and construction crews gather at the site, reviewing blueprints and double-checking every measurement. The placement of each tunnel section has to be perfect, because once it's underwater, there's no easy way to make adjustments. It's a high-stakes operation that requires nerves of steel and a steady hand. A special floating crane designed to handle these massive weights carefully lifts each tunnel section and lowers it into the water. Imagine trying to place a Lego brick at the bottom of a swimming pool, except this Lego weighs thousands of tons and must fit exactly into place. The crane operators work with incredible precision, guided by divers and underwater cameras, to ensure each segment lands perfectly in the trench. Once a section is in position, engineers line it up with the previous segment. To create a watertight seal, they use enormous rubber gaskets. Think of them as supersized versions of the seals you might find on a jar lid. These gaskets are squeezed between the tunnel sections, ensuring that water stays out and the tunnel remains dry inside. The process is a bit like gluing 2 pieces of clay together, but with technology and materials designed to withstand the crushing pressure of the water above. With the sections connected and sealed, the next step is to lock the tunnel in place. Crews backfill the trench with sand, gravel, or other materials, covering the tunnel and anchoring it securely to the river or seafloor. This not only protects the tunnel from shifting, but also helps it blend into the underwater landscape, hidden from view, but ready to serve its purpose. The final stage happens inside the tunnel itself. Workers remove the temporary bulkheads, connect the interior sections, and install lighting, ventilation, and safety systems. The once hollow segments are transformed into a continuous, functional passageway. After months or even years of planning and construction, the tunnel is finally ready for traffic, whether it's cars, trains, or even pedestrians. So the next time you drive through an underwater tunnel, remember, you're traveling through a structure that was built like a giant, muddy, high-stakes art project. It's a testament to human ingenuity, creativity, and the ability to turn even the most challenging environments into works of functional art. From sculpting massive blocks on land to assembling them beneath the waves, building underwater tunnels truly is the art of terracotta on a scale the world has never seen before.